So if I sent a signal to you in another planet and you're receiving it, you don't have to build a large dish, right? You can just build a small dish. And thinking back to panoramic SETI, we use, these very small 20-inch lenses, half meter size lenses. Mm-hmm. And even if you do the calculations, you can take Earth's technology today, go 1,000 light years away, take a laser, shine it back to Earth, and our little dish will detect it. That's how bright lasers are. Mm. So lasers became this kind of realm in optical SETI as an interesting realm to look at that wavelength. And by optical, I mean visible light. Mm-hmm. Now, if you're going to send signals, in between stars, there's gas and dust, right? And this is why you probably will say, well, you should probably, if you're communicating thousands of light years away, communicate at radio wavelengths. So, we knew this as SETI scientists, right? So one of the arguments, in fact, is if you were to use a laser or use a beacon that's not at radio, maybe you would do infrared, right? And this led into our team also building another kind of like the first near-infrared SETI instrument, which I was interested in early on, to get to those wavelengths of light as well. But, it's funny, over the years, we always use this kind of anthropomorphic, am I saying that right? Anthropomorphic view of our technology and how we would do detection. Right. And if you go out in the public and you give public talks, they'll say, well, how do you know they would use a laser? Wouldn't they use something else? And they would give a word to something probably in science fiction. Phaser. Yeah. Mm-hmm. And you're like, I don't. But light is everywhere in the universe, right? Mm-hmm. And in truth, we're not necessarily detecting lasers. We can detect anything at visible light that would make a bright flash or look unusual to nature. And everything in SETI is about detecting something that looks unusual, that, natural phenomenon aren't producing. And that's true at radio wavelengths as well.
What are the most significant background or systematic sources of astrophysical contamination?
At optical SETI, we really don't know yet. Most of the things, I think, for our program like panoramic SETI, the things that we may detect the most now are like satellites. So kind of Earth technology. We detect a lot of planes, satellites, even people talk about sprites in the upper atmosphere. So kind of local to us. That's true in radio SETI too, right? We talk about radio interference. Yep. And most of radio SETI is removing our own Earth signal from that. Yeah. Astrophysically, the exciting part is we don't know.
Would pulsars be something?
Potentially, yes. One of the astrophysics things is we have LIGO, of course, with gravitational wave discoveries. If we have these large angles of field of view, perhaps we could correlate an event that may produce what we call an optical counterpart to it.
Multi-messenger.
But nobody's detected it. Yeah.
And then do you have a protocol, the signal comes in and they're talking with, Proxima Centauri, or you see something of interest. Do you guys have a protocol for what you would do as the PI, as the, what would you do if this comes in, or is that not?
No, it's a great question, because we get this question a lot about what we would do, and people have their, sneaky suspicions of whether we get taken away from the men in black. We have candidate signals, as in experimental, experiments. You have kind of false positives, as we say, that can occur from your instrument as a noise, or it's a signal like a satellite. So we have protocols that do verification. So we have whether, we flag it like this is an exciting candidate or not. And then we go down and do the checklist to see if it's something internal or if it was correlated with something else. It usually is very unexciting. So we try not to call New York Times in most cases. But the question is, if there is something exciting, we do have a proclamation that we would declare it on Astronomer's Telegram, just like we would for any other transient source, to get other facilities to follow up.
Obviously the question of, the rationale for another civilization to communicate with us. I mean, there's a famous quote from Stephen Hawking where he says, basically trying to message to other civilizations is like ringing galactic dinner bell.
To serve men, it's a cookbook.
We be cautious and not send out, beacons that say that we're here. I mean, not that that's something you're directly involved with, but what's your position on that type of messaging to extraterrestrials?
Yeah, this is the concept of METI. It's a really interesting ethical conversation, right? There's a twofold question here. One is if you think there's a galactic civilization out there, you don't go out in the forest and scream that I'm right here, right? That's another phrase that's used. That's interesting. Of course, we're constantly leaking. I think more of it comes into kind of an ethical question about representing humanity. And so, as you know, there have been, people with means that go out and have taken radio dishes taken their favorite rock album and broadcasted it to space. Is that the best representation of humanity? Should there be kind of United Nations protocols about messaging over time? There was a lot of work into the Voyager message on how to represent this and how to represent planet Earth in general. I think we're a little young in our infancy to send out messages, but
and the risk might outweigh the rewards. You mentioned earlier, about looking for, not maybe techno signatures, but maybe just biosignatures from aliens in our own solar system. So I have an argument I'd love to run by you. This is a meteorite. This is Chelyabinsk meteorite. I have a meteorite, and I actually have a Martian meteorite that came from Mars. This is not that. This is actually yours to keep, unlike the Martian meteorite. So I'll let you take one of these.
Wow.
So this is a chunk of Argentinian gold. It's actually iron, nickel, cobalt. So, and you too can get it out there. As you know, go to my website, briankeating.com/list or /YouTube or /whatever. Go to /list. I'll actually cut out the YouTuber. So go to briankeating.com/list. And if you're like Shelley and me and you have a .edu email address, you get one guaranteed if you live in the US. So go to briankeating.com/edu and you'll get one, and you'll get some information about that one. Now that one came here via gravity. I also have one that came from Mars, as I said. And, I scanned it for life, never found any life on it. But the point I guess I'm trying to make is the fact that we don't see life on Mars. Okay, it would be a long shot, but can we use the non-observation of maybe techno signatures in our own solar system? Does that set any limits on the fecundity of life in the universe, or is that too limited a scope to project into the rest of the galaxy?
Well, as you know, the cosmos and our Milky Way is vast, and something that's always humbling as an astronomer is the distance between stars. Yeah. I think the only thing you could say is something about interstellar travel and the number of people taking vacations here in our solar system. Now, for Mars, I think more of it's, we take rovers there, as you know, to look not just at like whether life exists now. I would say more of the argument is, did life exist?
Yes.
Right. So if you look back 3.1 billion years ago, we know Mars had an ocean. We've done a lot of, discoveries about our own surfaces of other planets within our solar system. The question is, if this gets back into the origins of life, now, if we go to Mars and a rover says, wow, look, there was evidence of life 3 billion years ago, that it could start either on another surface besides Earth, that's a very statistical big deal, right? Because it means not only it can just happen on one surface, it can happen on another. And not only that, it could happen on another surface in the same solar system. That marvels me, actually, the most, Brian, because the fact that we can take, our resources today, do things like launch the Europa Clipper and go try to study the oceans of exo moon discovery. I know you had David Kipping on recently. Just thinking about life underneath Europa's ocean or Enceladus' ocean, the moon around Saturn, and thinking about organic materials and what organic materials could be there. That's fascinating to me, that one solar system out of billions, we're contemplating not necessarily, can life coexist just now in our own solar system, but could it have coexisted in the past?
Yes.
Right? We started this whole podcast thinking about, the probability of life. That should be a measurement, actually. That even in our scientific nature here in one solar system, we're exploring potential signs of previous life in other surfaces.
Yes. And when they may have overlap with life on Earth, because life on Earth kicked off.
Well, yeah, we can get into panspermia and other things. Here we go. But take that to all the other planets we're discovering now. James Webb Space Telescope's discovering. It's an incredibly exciting time. And when I started my career, I was always interested in this question of, are we alone? But I remember sitting in classes in undergrad, and people were talking about this rare Earth hypothesis, right?
Book somewhere here.
Yeah, that's so. Even in our little short sliver of time here, we know that's not true. Right. And again, this is marching down the Drake equation.
Yep. So now I want to pivot to a recent, I told my wife that, I saw a star being born when you were on the recent Nova, PBS Nova, which is, not only one of my favorites, one of the oldest, science and nature communications, and it's one of the best and well done. And so your episode was no exception. So talk about the genesis of that, if you will. How did you come to get involved with, PBS Nova, and talk a little bit about the role that you played and the other, contributors to that wonderful episode.
No, I've always been interested in studying techno signatures in this field of Are We Alone? And there's actually not that many people in this field, which is one of my things to advocate for, that we need, more brilliant people entering this field of SETI and astrobiology.